As we know that in last class we studied what is acceleration and what is the units of acceleration and etc etc. So now you tell me. So as we know, what do you mean by acceleration? Simply, if you want to say what is the formula for acceleration? Acceleration is equals to what? Final velocity minus initial velocity divided by time taken to change in velocity. Is it yes or no, guys? Yes, please respond.
Yes, sir.
Acceleration means final velocity minus initial velocity, and as well as what? The time taken to change in velocity. So that is what we can say. So as we know, we are talking about the velocity, so that we are keeping bar on top. Is it yes or no, Harish? Yes, that is what we say. Now, as we know, this is what the definition of acceleration. So the change in velocity per the time taken to change in the velocity is only we used to called as acceleration. Now, if it comes to here, in last class I taught you the two units of acceleration. One is CGS unit. Can anyone tell me what is the CGS unit of acceleration? Centimeter per second
per second.
And if we take the SI unit, we used to say what is the SI unit of acceleration?
Meter per
second square. Understanding? Meter per second square, or we can say m second inverse. Understanding? Inverse 2. So that is what we used to say acceleration unit. So we are having two kinds of units. One is CGS unit and another one is what, guys? SI unit. Yes or no? If it comes to the today's class, now let us discuss what is the acceleration. Suppose if it is uniform acceleration, types of acceleration we can say. The first one is we can say uniform acceleration. Do you understand, everybody? Yes or no? Now you tell me, if the car speed is continuously, car velocity is continuously increasing, so that we can say acceleration or accelerating or not, car speed is increasing. So is it accelerating or not? Please respond.
Yes,
Accelerating.
So that is what? So accelerating. So if we take here any kind of car, understanding, or bike, everything, if the velocity of the car is keep on increases, then we can say car is in acceleration. Is it yes or no? Will you accept that? Yes? Now.
Sir, with respect to time, sir.
What, Harish? What? Yes, please respond. Ask me. Somebody is asking something.
Sir,
Yeah.
sir, with respect to time, no, sir.
Respect to time. That is what I am saying. You understand, Harish? With respect to time, always.
Yes, sir.
Understand? For example, you have a car now. So now I given you to drive. I asked you to drive the car. Now starting it will be what? 0 kilometer per hour. Now it will increases to 10. 10 become 20. 20 become 30. 30 become 40. 40 become 50. 50 become 60. 60 become 70. Like that. Keep on the velocities keep on increases. Is it yes or no? Yes, please respond.
Yes,
What? So, with respect to time, the velocities keep on increases, so that if the velocity is increasing, then we can say body is in acceleration or not. Parishkar? Then we can say
Yes.
body is in acceleration. So, when the velocity of the body is increases, then we can say the body is in accelerating. The body is in what? The body is
accelerating.
accelerating. Do you understanding? Any body, if velocity is increasing, then we can say the body is in accelerating. Same way, if the velocities keep on decreases also, then also we can say body is in acceleration or accelerating. But it is increasing, and this one what will come? If you are decreasing the velocity, then what will come? This is decreasing acceleration. Do you understand, everybody? So in this case, the decreasing acceleration only we used to call it as some other name. That is what we used to say retardation. What we used to call, guys? Retardation. Understand? That also we will study in our today's class. Now, if you notice it, coming to the uniform acceleration, that is what our now present target. So, simple definition, if you want to make, the uniform acceleration means any kind of object or any kind of body, understanding, as a uniform acceleration means if it travels Understanding, always must travel in which direction? Some particular direction, yes or no? So when you want to say body is in a acceleration, the body must travel in straight line. What we can say, guys? The body must travel in what? It must be traveling straight line first. Why straight line? Anybody can tell me here? Danishkar, Reddy, anybody? Why it is straight line? Because then only we can mention the particular direction. Yes or no, guys? Yes, please respond.
sir.
So,
Yes, sir.
direction. If there is no particular direction, then is it called as speed or velocity?
Speed.
Speed, that is what? But acceleration is rate of change of velocity. It's not that rate of change of speed. So that is why we will use a word called as always the first thing. If you want to say body is in uniform acceleration, then first of all you have to say body must be in which one? It must be in which path, guys? It must be in straight line. Do you understand, everyone? Yes or no? Please respond. Then
Yes, sir.
straight line, then what should be? How the velocity should increase? Anybody can tell me how the velocity should increase? Equal. Understand, it is the velocity should increase as if we'll take equal changes in velocity in equal interval of time. Then that is what we can say. The body is in which acceleration, guys? Uniform acceleration. For example, the body. I asked Danishkar to start a car. Now his car is in what? 0 kilometer per hour. Let me imagine towards to east. This is what the direction. What is that, guys? What is the direction?
East.
Now, okay, now you can take here. Now, after 1 minute or after 1 second, his speed will become, his velocity will become 10 kilometer per hour. Now, after another minute, his speed will become how much, guys? Anybody? It must be a uniform.
20 kilometers.
20. After 1 minute again, then how much it is? 30 kilometer per hour. After 1 minute, again, how much it is? 40 kilometer per hour. So like that, then rates, have you noticed that everywhere you can subtract the difference? What is the difference? What is the change in velocity?
Increasing, sir.
Increasing velocity, but how much it is from one point to another point? From
10
one point to another point. 10 kilometer per hour. Yes or no, guys? So every 1 minute, the velocity is increasing how much, guys? Velocity is increasing how much? It is
10
increasing
kilometers.
10 kilometer per hour per 1 minute time. That is for example I'm saying. So that is what we can say. In this case, the body is in which acceleration, guys? The body is in
Uniform acceleration.
you understanding? So rate of change of velocity is uniform. Then we can say the body is in uniform acceleration. Means the whatever the velocity changes, it must be same with a same equal interval of time. That is what we used to call as uniform acceleration. Have you understand, Reddy, Danishkar, everyone? So
Yes,
it needs to cover what? If equal changes in velocity takes place in equal interval of time, then we can say the body is in said to be what, guys? Body is said to be in which motion? Vartini? Uniform acceleration. So please all of you write. If the change in velocity of the body, if the change in velocity of the body, if the change in velocity, Danishkar, have understand, Arun Kailash? If the change in velocity of the body, if the change in velocity of the body is equal in an equal interval of time, is equal in an equal interval of time, then the body is said to be in which motion, which acceleration, guys? Then the body is said to move. Then the body is said to move. Said to move what, guys?
Straight line.
Uniform acceleration. That is what. Any doubt? Anybody? Please ask. Clear? What do you mean by uniform acceleration? Have you understand? So velocity should change what? Velocity should change uniformly. Do you understand, everyone? That is what. So let me write example. One example. All of you do it example. Let me take 4 points. Understand? So this is what the 4 points. All of you notice it. A, B, C, and as well as let me take D. And if you want, you can take E also. Okay. So what is this point? A point, B point, C point, and D point, and E point. Okay. Now let me take for example A point. The velocity is 10 meter per second. Now B point, how much it will become, guys? 20 meter per second. C point, 30 meter per
30.
second. For D point, 40 meter per second. Clear, everybody? Yes or no?
Yes.
And E point, what will happen? E point, what will happen? E point, how much it will come? E point, anyone?
0, sir. It will be in the.
0. E point,
It will end.
50 meter per second. Yes or no? That is what. Now you can take the points. What is the points here, guys? A, B, C, D, and as well as E. Now you tell me. So from one point to another point, if you'll go anywhere, the body is moving in a straight line. So if it is a uniform acceleration, what is the first condition? Gokul, what is the first condition you have to remember? Body must move in a which direction? Body always must move in a straight line. Do you understand, everybody? Body must move in a which direction, guys? It must move in a straight line direction. Then we can say A, B, C, D, and E points. They are the such that it covers the distance of. What is the distance covering here? Anybody can tell me? What is the distance covered? A to B. AB is the distance covered by how much time? Hari?
150, sir.
For how much time? A
1 second.
for 1 second. Next, BC is the another distance covered by how much seconds again? 1 second.
1 second.
Next, CD is the another one which is covered by the distance how much time? Another how
1
much time?
second.
For 1 second. So C to D. So if you take here AB, BC, CD is all equal and as well as D. Now if you take the interval of time, what is the interval of time, guys? From one place to another place, what is the interval of time?
1
Everyone
second.
please respond. So we can say AB is equals to BC. BC is equals to what? CD. CD is equals to D. So all the distance between them is same. Now, what is the time taken, guys? What is the time in this picture? What is the time you are observing? How much time it is taking? How much time?
4 seconds.
Understanding? For 1 second. So you can take the velocity of the body at A, B, C, and D. You can say 10, 20, 30, 40, and 50 respectively. Now if you take position. So what is the position if you take, for example, so what is the position at position? What is the positions you can take, everybody? So A, B, C, D, and E. Now, this is what our position of the body. Yes or no? Try to communicate. Okay. Now, what is the time, guys? Time. Anybody can tell me? Time T is equals to what? A, 0. Understanding. Next, 1 second, 2 second, 3 second, 4 second. Yes or no? Please respond. Now, 1 minus 0. What is the time taken from A to B? From A to B, what is the time taken?
1 second.
1 second. That is what we can say delta T. You understanding? Seconds. Okay, everybody. Now, next B to C. What is the time taken? What is the time taken? 1 second. Next
1
C to
second.
D. Also 1 second. How?
1
This
second.
one 1 minus 0. This one 2 minus 1. This one 3 minus 2. And last one D to E also. How much time? 1 second. That is what? 4 minus 3. So now, Danishkar, have you understand, Danishkar? So delta T you got. Yes, now delta T is over. Delta T after velocity. Velocity, tell me, guys, what is the velocity? Velocity points. Velocity at every point. Velocity 10 meter per second. B point 20 meter per second. C point 30 meter per second. D point 40 meter per second. E point 50 meter per second. Now, what is the delta V? Anybody can tell me delta V means what? Delta V. Harish? Yeah. Final velocity minus initial velocity. In these cases, what is the delta V? 20 minus 10, which is equals to 10 meter per second. In these two cases, anybody? 30 minus 20, which is equals to 10 meter per second. Now, in this case, 40 minus 30, which is equals to again 10 meter per second. Now, last one, 50 minus 40 is also is equals to 10 meter per second. This is only what is to call change in velocity. Yes or no? Please respond. Change in velocity, delta V. Now, what is the acceleration formula? Anybody can tell me? What is the acceleration formula? As I told you. Not Harish. One more formula I said. Now already you know delta T and delta V. Then what is the formula? Acceleration. Acceleration is equals to what is the formula, guys? Nobody is responding. Yeah, so acceleration is equals to, you can take formula delta V divided by what? Delta T. Now, case 1, let me take all the cases. So now case 1, if we'll take delta V is 10 meter per second, time is equals to how much, guys? 1 second. So it will turns into 110 meter per second square. Next, case 2. How much it is again? 10 meter per second per 1 second, which is equals to again how much? 10 meter per second square. That is what? So this is delta T and this is delta V. So everywhere you check it, 10 divided by 1. How much? 10 only. 10 divided by 1, 10. 10 divided by 1, 10. 10 divided by 1, 10. But units is very, very important. So rate of change of velocity we used to call it as acceleration. So that is what everywhere we used to get how much ready? We'll get rate of change of velocity, which is what? Acceleration, meter per second square will come. Do you understand, everyone? Yes or no? Please respond. This is what we used to say, rate of change of velocity. So this is the example which I want to say for which acceleration? For which acceleration? Uniform acceleration. Now, out of all you 6, you tell me how many of you understand uniform acceleration? Anybody? Doubt? Gokul?
I understand, sir.
So now if you'll understand, so if it is uniform acceleration, what is the first condition? What is the first condition? Anybody? Body must move.
Travel in a straight line.
Yeah, that is.
Straight line, sir.
Others are not saying. So body must travel in straight line.
Straight line.
Yeah, if you want to get uniform acceleration, then change in velocity must be same and body must travel in what? A particular direction. That is why we can consider straight line. So now this is what the thing. Have you solved it, everybody? Any doubt, anybody, you can ask me. So this is what is called as uniform acceleration. If you not understand, kindly let me respond. Yes, Harish?
Sir?
Now, if you take your textbook also, you'll never be having any kind of uniform acceleration graph. But if you draw uniform acceleration graph, how it will come? Any guess? Straight line. How it will come back? Straight line will come. That is what?
Straight line.
Is linear graph. So uniform motion, uniform speed, uniform velocity, same way, uniform acceleration. Always it will come how? Always it will come straight line. Or we can say what, guys? We can say linear graph. What we used to call this one? Linear graph. Do you understand, everyone? That is what. So uniform motion also will give you straight line. Uniform speed also will give you straight line. Uniform velocity also will give you straight line. Now uniform acceleration. So that 4 points or 5 points. Please all of you draw the graph for 5 points. So now what will come? Anybody? So here one more point you can imagine. So that point only, what point we used to call? That point is the last point of our graph. So that is what is this? So now you can extend this one y-axis and you can make so dotted lines. So equal distance. Harish, understand, Harish? It must be having equal distance. Okay. So that is what. So how is the graph is coming? What is the graph coming, guys? Linear graph. What is the graph? Linear graph. So draw neatly linear graph. This is what? Velocity and time. So this is the graph for which one, guys? Uniform acceleration. Understand, Ra? Ready? Gokul, this is what we used to call as
Yes, sir.
uniform acceleration. So uniform acceleration also, what is a graph? X-axis time and y-axis who guys? Y-axis who? Y-axis velocity.
Velocity.
Okay, velocity. Then it will give you always the graph is straight line. So sir, here not starting from zero. Why it is not starting from zero? Body is already having initial velocity. In our question, what is the initial velocity? Already body is having initial velocity of how much? 10 meter per second. That is why here graph is starting from 10 meter per second. But basically if we'll draw uniform acceleration, then body will start from where guys? Body will start from zero only. Is it okay everyone? Harish, Vardhani, that is what. So the uniform acceleration graph also, it is what? Straight line. That is what you have to remember. And this is the graph you have to draw for the example sum. But neatly you have to draw it with the equal distance. Okay, everybody? Equal distance, equally you have to draw perfectly. Name it also properly and make it everything clear in our classroom. Any doubt guys? Yes, please respond. So this is what we used to call as uniform acceleration. Now, if you'll understand this uniform acceleration, then the second type of acceleration, that is what is that guys? What is that guys? Non-uniform acceleration. What is to call? Non-uniform acceleration. So definition itself we can understand. What do you mean by non-uniform acceleration guys? Oh, Harish, one thing, 1 minute. Everybody wait. Example I forgot. Example of uniform acceleration, right? A freely falling body poses uniform acceleration. A freely falling body, example. A freely falling body, freely falling. Ready? Freely falling means what ready? Gokul, respond, Danishkar.
Sir,
Falling
it is
body.
falling from like somewhere.
It is thrown from the top of the terrace or some sky and all. Sky means not that much part, like normal I'm saying. From the helicopter somewhere. Like some object it will throw from the top of the building, then that is called as freely falling body. Okay guys? Freely falling body possesses uniform acceleration. Possesses uniform acceleration. Now, uniform acceleration is over. Next, opposite to acceleration, uniform. What is that? Opposite to that, non-uniform acceleration.
Sir, I have a doubt, sir.
Ask me, Harish.
Sir, can I just go up?
Yeah. 1 minute, Harish. Yes, non-uniform acceleration. Tell me, Harish.
Sir, here we can cancel the seconds, no, sir. 10 meter per second by second. Second can cancel.
That is what, Harish, you are doing mistake. Be very careful, Harish. Harish, careful. Acceleration units is C. Meter velocity. Velocity, what? Change in velocity. Change in velocity, what is the unit? Meter per second. Yes or no, Harish? And the time is what? Second. Okay. Now, this is what like this. Meter per second is the unit like this, divide by second. So here nothing is there, by 1 will be there. Harish, mathematics you can see. A by B divided by C by D. How we can write? A by B into D by C. Yes or no, Harish? Yes?
Yes, sir.
Here also nothing is there means 1 will be there. So how it will turn? Meter per second into 1 by second. So that meter per second square. Okay? Understand, Harish?
Okay, sir.
That is what will come. That is what
Yes,
actually
sir.
clear. What you ask, for example, Harish, like this it is there. Second divided by second, then we can get cancelled. But up to 1 more meter is there, so that it is not possible to cancel. Okay, wow.
Okay, sir.
Harish. Okay, that is what you have to understand.
Okay,
That's fine. So now very good. So now this is what. Now what is the second type of acceleration, guys? Anyone? What is second type?
Non-uniform acceleration.
Non-uniform acceleration. Even definition itself, you can replace, you can get it. What is that? Here they are saying a change in velocity of the body is what? Equal. Understanding? So there what will write? There what will write?
Unequal in equal interval.
Unequal in equal interval of time. That is what we can say. Non-uniform acceleration. Please all of you write. If unequal changes in velocity, if unequal changes in velocity, if unequal changes takes place in velocity, then what is to call, guys? Takes place in velocity in how much? Unequal changes takes place in velocity. Okay, in how many equal interval of time? Equal or unequal interval of time? In equal interval of time. Okay, unequal changes takes place in velocity in equal interval of time. In equal interval of time is known as what is to call? Non-uniform acceleration. Any doubt, please respond. Non-uniform acceleration. Vartani, I understand. Open your mouth. Clear, everybody?
Yes, sir.
Yes, that is what. So then we can say the body is said to be in non-uniform acceleration. Any example of non-uniform acceleration? Let me see who will give example of non-uniform acceleration. Example of non-uniform acceleration. You can say that anything. Suppose you are traveling in a car. Is it possible to maintain the uniform acceleration, Reddy? Your father is always
No, sir.
maintaining the same rise in acceleration.
No, sir.
Yeah, driving car, understanding? Driving car, riding bicycle. So this all what is to call? Example of what? Non-uniform
Non-uniform.
acceleration. So let me see who will say the graph. How the graph will be? Here time and here velocity. What will be? Non-uniform acceleration graph. Anybody?
So it will go up.
It
Sir.
will be curved.
Curved path.
It will be
Understanding
curved.
curved path, so that we can say it is non-uniform acceleration. Ready? Not going up. You have to say curved path. Okay, ready?
Yes.
Yeah. Everyone, Gokul, I understand Gokul.
Yes, sir.
Kailash. So, like you can see, non-uniform motion. Next, non-uniform speed, non-uniform velocity. Now, last one is what? Non-uniform acceleration. Okay. So, everything we used to call as same graph. What is the graph? Curved graph. What is that? Graph is curved one. That is what you have to remember. Any doubt, boys? Please respond. Girl, that girl will never speak. That's fine. This is what we used to call as uniform and non-uniform acceleration. Now, uniform, non-uniform over. Now, you tell me, suppose your father is driving a car. Is he continuously increasing velocity only? Yes, please.
No, sir.
No. When the situation will come, then what will happen? He will decrease the velocity. Yes or no? Yes, please respond. Velocity decreases. So in this case, if velocity increases, we used to call it as acceleration, or we can say positive acceleration. What we used to call, guys? Arun Kailash? Positive acceleration. Okay. That is what. So if the velocities keep on increases, then we can say it is positive acceleration. Anybody doubt? Anyone? You can ask me. Now, if velocity is decreasing, if continuously velocity is decreasing, like when we want to stop, we will decrease the velocity or increase the velocity. Anybody?
Decrease the velocity.
Increase the
Velocity. Do you
Decrease the
understand?
velocity.
So that is what we can say. It is the decreasing velocity. So now the decreasing velocity only we can say retardation or deacceleration or negative acceleration. How many names we can call? So this one you can write example, driving car in a busy road. Okay. or traffic road, busy road, or anything, normal road also we cannot go very fast. Same velocity we cannot increase. That is what. So now, if it comes to that, the decreasing velocity only, I am saying three names. What is the three names, guys? Retardation.
Retardation.
Understanding? Or we can say what? Deacceleration. What is to call, Harish? Deacceleration or negative acceleration, we can say. Okay, deacceleration, or we can say, see, acceleration A won't come again. Disacceleration, we can say deceleration, or we can say negative acceleration. Negative acceleration. What do you mean by negative? Opposite word is positive. Positive means increasing acceleration. Negative means what, guys? Positive means increasing acceleration. Negative means decreasing acceleration. Keep in mind, decreasing acceleration also we can call it as what? Retardation, or we can say deacceleration. Is it okay, guys? Everybody? Yes, please. That's part. That is what. So, if the body is increases, that what we used to call, guys? Positive acceleration. Yes or no? Yes, please respond.
Yes, sir.
Yeah. So, and if your body velocity of the body is decreases, then what we used to call, everybody? If the velocity of the body increases, positive acceleration. If the velocity of the body is decreases, negative acceleration.
Negative.
Now you tell me, both we used to measure in the same manner. Yes or no? Both we used to measure in the same manner, but
Yes, sir.
negative acceleration we used to get decreasing or increasing? Decreasing or increasing?
Decreasing.
Decreasing. Understanding? So retardation is measured in the same way as acceleration. So retardation also is equals to what? Change in velocity divided by time taken. So we can say retardation also same formula. Retardation we can measure in same way like acceleration. So what is the formula? Acceleration, change in velocity, understanding, divided by time taken. Is it yes or no, Harish? Yes. So what is the retardation formula? Anybody can tell me? Retardation means we can say change in velocity. What is that? Always final velocity. Final velocity minus, please respond, initial velocity divided by, yes, Harish, but reverse, minus sign will come. Okay, Harish? Decreasing, Harish.
Final velocity.
Harish. No, Harish. Decreasing, minus should come. Okay, Harish? Understand? Time take.
Yes, sir.
Okay, decreasing, we have to take always same like acceleration, but it is negative value will come. Do you understand, Harish? Now, everybody, others. So change in velocity divided by time taken. So again, the units also what? What is the units of retardation? Anybody? Arun Kailash, Danishkar. Units of retardation. Again, centimeter per second square, or we can say SI unit. What is the SI unit? Meter per second square. Understanding? So the same units of acceleration, because both are same. Acceleration means increasing velocity. Deacceleration or retardation means what? Decreasing velocity. That's all. Okay. Now, shall we solve one example, everyone? You can understand better.
Yes, sir.
Yes. Now, for example, let me take now when a car driver traveling at the initial velocity 10 meter per second. How much? How much, guys? He's traveling
10
initial
meter per
velocity.
second.
Already he is having initial velocity. Initial velocity U is 10 meter per second. Now he apply brakes. What has been done? Tanishkar? Brakes he applied. So if you apply brakes within 5 seconds, if you apply the brake, car will come to rest or speed will increases?
Rest.
Rest, sir.
Come to rest. So car will come to rest means what is the final velocity? Final velocity is 0. Understand? So if no movement, then body is in rest or not? Yes or no? So rest. So final velocity is 0. Retardation is equals to, please respond, retardation, or else you can write acceleration also. Retardation is equals to final velocity. What is the final velocity, guys? What is the final velocity? final velocity is 0, understanding, minus initial velocity is 10 divided by time is 5 seconds. So we can say 5 ones are 5 twos are. So what is the answer? 2 meter per second square. What is that, Harish?
Minus, sir. Minus 2.
Minus. Now that is what I'm coming here. Look into the board. Everybody look into the screen, everyone now. So retardation itself, what we used to call, Harish? Retardation itself, what we used to call? Negative acceleration. You understanding? Negative acceleration. So if you'll write retardation, then in answer, no need of showing the minus. Do you understand, everybody? No need of showing minus. Any clear doubt? Any doubt? Okay. Now, same question. Suppose, sir, I don't want retardation. I took acceleration. So acceleration only I took. Now, acceleration, it is decreasing acceleration or increasing acceleration? Decreasing or increasing acceleration?
Decreasing acceleration.
Increasing acceleration. So I can say by this time, all of you should remember, when I am mentioning instead of retardation, if I took, understanding, acceleration itself, then it should minus must be placed. Now this minus is indicating what? This minus is indicating what? Decreasing acceleration. What we used to call? Decreasing acceleration. Are you clear? So same decreasing acceleration. If you'll write retardation, then no need to show the minus sign. Why? Minus is already indicating decreasing itself. So that is what you no need to mention minus in final answer. Is it okay, guys? Yes?
Yes, sir.
Suppose if you mention